Hi everyone, welcome to my YouTube channel. In this video, I am going to explain about Kirchhoff laws. Mainly we have two different types of Kirchhoff laws. First one is Kirchhoff current law and second one is Kirchhoff voltage law. What is the first one? Kirchhoff current law and second one is Kirchhoff voltage law. First I am taking Kirchhoff current law. Kirchhoff current law. In shortcut it is KCL. Okay. So now coming to the statement of Kirchhoff current law, at any node or junction, sum of entering currents is equal to sum of leaving currents. What is the statement? At any node or junction, sum of entering currents is equal to sum of outgoing currents. Okay. So I am writing here, at any node or junction, at any node or junction, sum of incoming currents are equal to sum of outgoing currents. So this is the statement of Kirchhoff current law. So here I am taking one node. Okay. So let us say this is one node. Node is nothing but a point. It is junction. Okay. So I am assuming 3 incoming currents for this node. So these are the 3 incoming currents. One is I1, I2 and third one is I3. So next I am taking two outgoing currents, I4, I5. Okay. So this is the node. Okay. That is the node. For this particular node, I1, I2, I3, these three are the incoming currents and I4 and I5, these two are the outgoing currents. So now apply KCL here. Okay, what is the KCL statement? According to KCL, at any node or junction, sum of incoming currents are equal to sum of outgoing currents, right? So first write what are the sum of incoming currents. Okay, what is the sum of incoming currents? Okay, what is the sum of incoming current? We can take I1 plus I2 plus I3, right? So sum of incoming currents is equal to I1 plus I2 plus I3. That is equal to sum of outgoing currents. What are the sum of outgoing currents here? I4 plus I5. Okay. So from the statement we can write I1 plus I2 plus I3 is equal to I4 plus I5. Okay. So from this send this RHS side elements I4 and I5 to LHS side. Then what happen? I1 plus I2 plus I3 minus I4 minus I5 is equal to 0. I5 is equal to 0. From this equation we can say statement of the KCL in another words. Okay. So what is that? At any node or junction, algebraic sum of the currents is equal to 0. Right? What is the definition? At any node or junction, algebraic sum of the currents is equal to 0. So while taking the algebraic sum, so if you consider incoming currents are positive, then we should take outgoing currents as negative. So see here, I1, I2, I3, these are the incoming currents. So here we take in positive sign, right? So therefore we should take negative sign for outgoing currents. What are the outgoing currents? I4 and I5. So here minus I4 and minus I5. This is the statement of Kirchhoff current law. Okay, let me consider one example on this. I am taking one simple example for KCL. So this is the voltage V. So this is a simple circuit. So I am taking current delivered from this voltage source is 20 amperes. Current delivered from this voltage source is 20 amperes. So take this is R1, R2 and R3. Current flowing through R1 is I1 I am taking. Sorry, I am taking I2, I3 I am taking. Okay. So let us say current delivered from the voltage source is 20 amperes and I1 is equal to 5 amperes and I2 is equal to 10 amperes. Now I want I3. What is the I3 value? Apply KCL for this circuit. Okay. So what is the KCL? According to KCL, at any node or junction, sum of incoming currents is equal to sum of outgoing currents. So now find out the node. So here we have node. Okay. So here 4 branches meet at one point, right? So then we can take it as one node. So this is one node. Okay. For this node, now find out what are the incoming currents. Okay. There are 4 branches connected to this particular node. Out of 4, we have only one incoming current. What is the incoming current here? 20 amperes, right? So therefore, write 20 amperes. Therefore, incoming current, sum of incoming current is equal to, what are the outgoing currents? Here we have 3 outgoing currents for this particular node, I1, I2 and I3. Okay, right? I1, I2 and I3, right? So now we know I1 and I2 values. Substitute here. 20 is equal to 5 plus 10 plus I3 is the unknown value. Okay, so from this 5 plus 10 is 15. So therefore we can write I3 is equal to 20 minus 15. So therefore I3 is equal to 5 amperes. I3 is equal to 5 amperes. So here we can write 5 amperes. I3 is equal to 5 amperes. So like this we can calculate current in any resistor. This is all about Kirchhoff current law. Okay. Next I am taking KVL, Kirchhoff voltage law. Coming to the statement, in any closed loop, sum of voltage rises is equal to sum of voltage drops. Okay, simple statement. What is the KVL? KVL statement is sum of voltage rises is equal to, in any closed loop, sum of voltage rises is equal to sum of voltage drops. So let me write here, in any closed loop, sum of voltage rises equal to sum of voltage drops. Okay, this is the statement of Kirchhoff voltage law. So in any closed loop, sum of voltage rises is equal to sum of voltage drops, right? So I am taking one simple circuit diagram. Okay, battery voltage I am taking V, and this is the first resistor R1, second resistor R2 and third resistor R3, right? So when we connect the voltage across this particular resistors, some current flows through the circuit. So therefore I am assuming that current is I. Okay, due to current flowing through resistor, we will get some voltage drop. So I am assuming voltage drop across resistor 1 is V1 and voltage across R2 is V2 and voltage across R3 is V3. So these are the voltages across respective resistors. Okay. So now coming to the statement, in any closed loop, sum of voltage rises is equal to sum of voltage drops. Okay. So now the question is, what is voltage rise and what is voltage drop? Okay. So voltage rise is nothing but voltage across the active elements. So that means voltages across the batteries or sources. Voltages across the sources are nothing but voltage rises. Now voltage drops are nothing but voltages across passive elements. So that means voltages across resistors, right? So therefore from this definition, from the statement, we can write sum of voltage rises. So in the circuit we have only one voltage rise, that is V. Sum of voltage rises, that means V is equal to sum of voltage drops. So what are the voltage drops? Here we have three voltage drops, V1, V2 and V3. So therefore take sum of voltage drops, V1, V2 and V3. Okay. So we know that V1 value. What is V1? V1 is the voltage drop across resistor 1. V1 is the voltage drop across resistor 1. Now apply Ohm's law here. Okay. What is the Ohm's law? So from Ohm's law, I want V1 is equal to, okay. For this particular resistor, voltage is V1, resistor is R1 and current is I. Okay. If you apply the Ohm's law, then we can write V1 is equal to I into R1. Similarly, I want V2 is equal to. So what is V2? It is the voltage drop across second resistor R2. Okay. Voltage value is V2 and resistance value is R2. What about current value? Same I. So this is a simple series circuit, right? So in series circuit, current is same amount of current I flows through the R2 also. So therefore current is I only. So apply the Ohm's law here. From that we can write V2 is equal to I into R2. So similarly we can write V3 also. V3 is equal to, V3 is the voltage drop across third resistor, that we can write it as R3. Okay. So now substitute these three values here. So then what happen? So next V is equal to, I am substituting these three values, I into R1 plus I into R2 plus I into R3. Okay. Next here we can take I common. So therefore V is equal to, if I take I common, R1 plus R2 plus R3. So from this I can write I is equal to V by R1 plus R2 plus R3. So this is the final equation. So by using this we can calculate the total current I. Okay. So next from this equation, if I take this equation is 1, from this equation I can write like this, V minus, so I am sending all RHS side elements to LHS side. So therefore V minus V1 minus V2 minus V3 is equal to 0. Okay. So from this equation also we can say definition of the Kirchhoff voltage law in another words. So from this equation, Kirchhoff law statement is, in any closed loop, algebraic sum of the voltage rises and voltage drops is equal to 0. In any closed loop, algebraic sum of the voltage rises and voltage drops is equal to 0. So here what are the voltage rises? V is the voltage rise and remaining 3 are the voltage drops. Okay. So already I explained in Kirchhoff current law, while taking algebraic sum, consider one as positive, another one as negative. So here I consider voltage rise as positive and voltage drops are negative, right? So this is the definition in another words. Okay, let me consider one example. I am taking one simple circuit. Hundred volts, 25 ohms, and 50 ohms. Now I want what is the current flowing through this circuit by using Kirchhoff voltage law. Okay, what is I? What is I? Using KVL. What is I? By using KVL I want. Okay, follow the second statement. What is the second statement? So according to the second statement, in any closed loop, this is the closed loop. In any closed loop, algebraic sum of the voltage rises and voltage drops is equal to 0. Okay, while doing that procedure, follow these steps. So first take what is the current direction. Okay, here what is the current direction? Current direction is clockwise direction. Okay, this is the current direction. I is the current. So in next step, give polarities for the passive elements. Okay, how to give polarities for passive elements? Remember this point. Okay, so for all passive elements, current entering terminal should be considered as positive. Current entering terminal should be considered as positive, and current leaving terminal is considered as negative. Okay, so for this particular 25 ohm resistor, what is the entering terminal? This is the entering terminal. At this point, current is entering to this resistor, right? So therefore I am taking positive. So you are leaving the current, right? So therefore negative. So next, same amount of current flows through the circuit and entering this point. Okay, for this second resistor entering at this point. So this is positive and this one is negative, right? So follow the same direction. So here current is entering, therefore positive, and it is leaving, so therefore it is negative. Okay, now apply KVL. Okay, so simple, it is follow the current direction, follow the current direction and write voltages. Okay, so from this point I am starting. So here I am entering negative terminal of the 100 volts source, right? So therefore write apply KVL. Okay, so here I am entering in negative terminal of the 100 volt source, right? So therefore write minus 100, follow the same direction. So here I am entering in positive terminal of the resistor. Okay, what is the voltage drop here? We can write voltage drop V is equal to I into R, right? So I value is this one and R value is 25. So therefore we can write IR, that is nothing but 25 into I. Okay, plus 25 I. So same, follow the same direction. So here current flows through this resistor also. So therefore here also we will get some voltage drop. So what is the voltage drop here? Same, current into resistor, that is 25 into I plus 25 I. Because I am taking why I am taking plus? Because here I am entering in positive terminal, right? So therefore follow the same direction. So here also I am entering in positive terminal, therefore plus, write the voltage drop here. What is the voltage drop? 50 into I is equal to 0. Algebraic sum of the voltage rises and voltage drops is equal to 0. So from this I can write 100 plus 25 plus 25, 50, 50 plus 50, 100. So therefore 100I is equal to 0. So from this we can write 100I is equal to 100. So therefore I is equal to 100 by 100 and I is equal to 1 ampere. I is equal to 1 ampere. How much current flowing here? 1 ampere. 1 ampere current flows through this circuit. So this is the procedure for Kirchhoff voltage law. Like this we can calculate total current after getting the current, and also we calculate voltage drop across each and every resistor. Okay, for example, if I want voltage across this particular resistor, just multiply this 25 with current. So 25 volts is the voltage drop here. So similarly here also 25 into current. So here also we will get 25 volts. So next, same current flows here. So how much here we will get? 50 volts. If you observe the first statement, so what is the first statement? This is 25, not 20, 25, because 25 into 1 is 25. Okay. So what is the first statement? According to first statement, in any closed loop, sum of voltage rises is equal to sum of voltage drop. So let's check that one. What are the sum of voltage rises? 100. 100 is equal to, what are the voltage drops? 25 plus 25 plus 50, that is also 100. Okay, both are same, both are same. This is the procedure for Kirchhoff voltage law. Thank you.